So now we're going to look at something called sequences, which is basically just a pattern of numbers that you're given. And within that term sequences, we actually have two different types. There are the explicit and the recursive ones that we'll be looking at today. And this information can be found in Chapter 9, Section 3 of your textbooks. So first, just to talk about sequences in general, they are an ordered progression of numbers. What that means is that there is some kind of a pattern that helps you go from the first number in the pattern to the second number in the pattern to the third number in the pattern, etc. And in this first sequence, you can see that the pattern is adding 3. So I can find the next term and the next term and the next term, etc. Here's another example of a sequence. This one is multiplying by -2. So I can find the next term and the next term and the next term. And then here's probably the trickiest one. This one is actually numbers being squared. So I see 1 squared, 2 squared, 3 squared, 4 squared. So I could fill in the next number, and the next number, and the next number. So in each case, a sequence is just some sort of ordered progression. There's some kind of a pattern so that we could find more terms if we needed them. Well, there's a more specific term called an explicit sequence where they will define a short formula for us. And the advantage to this is that then when they say what is the nth term, well, the formula will have an n in it. So you could just plug in n is 10 and compute the answer. That's what's nice about an explicit sequence. So if you want to know the 5th term, plug in n is 5. If you want to know the 30th term, plug in n is 30. The other thing that's great about this one is we don't need to know all of the terms in between. So when you're given an explicit sequence, it's very easy to find the specific terms you're looking for. In contrast, we have a recursive sequence. For this one, they won't give you a formula that just says perform this operation on n. What they will do instead is they will give you the first term in the sequence, and then they will give you the pattern for finding the remaining terms. Like they'll tell you mathematically that you need to add 3 to find the next number. Or they'll tell you mathematically that you need to multiply by 2 to find the next number. The disadvantage of a recursive sequence is if they ask you to find the 10th term, you can't just jump to plugging in 10. You would have to find the second term, then the third, then the fourth, then the fifth, and you have to go through an order filling in all the numbers along the way. So here, let's just focus on explicit sequences for a moment. The nice thing about explicit sequences is you're able to just plug in the number for any term you're looking for. So if you want the 50th term, plug in 50. This method is great because it lets you skip around in the sequence. You don't have to find all of the other terms. You only need to find the ones you're asked for. So here's an example of what an explicit sequence looks like. You can see that we have an expression defined with n and some operations being performed by it. In this case, we have n being squared, and we're subtracting 1. This a sub n is just our notation for referring to different terms in the sequence. So a sub n is like the general way of saying plug a number in for n, and that'll give you a specific term. So a sub 1 is the first term, a sub 2 would be the second term, a sub 3 would be the third term, a sub 4 would be the fourth term. So this is just the naming convention. That way we're able to communicate to each other which number in the pattern are we talking about or are we looking at. So they wanted the first 6 terms in the pattern, so I need a sub 1 through a sub 6. And they want the 100th term, so I'm also going to have to find a sub 100. So to find the first term, you just plug in n is 1. And they gave me a rule. It's the number you plug in squared minus 1. So the first term means n is 1, and 1 squared minus 1 is 0. So the first term in my pattern, if I were just listing them out, is 0. Then for the second term, well, it's the number you plug in minus 1. So square the number you plug in, which is 4, and then if you subtract 1 from that, you get 3. So the second number in my pattern is 3. When I want to find the third term in the pattern, I plug in 3. You just keep performing the same operation to it over and over and over again. So now we're saying what is 3 squared? 9. Minus 1 is 8. So there's the third number in our pattern. And continue repeating this system. So 4 squared minus 1, 16 minus 1 is 15. And the fifth term, 5 squared minus 1, is 24. And the sixth term, if you plug in 6, you get 35. Now this one did also ask us to go far ahead in the sequence, skip a whole bunch of terms. So I'm just going to use a dot, dot, dot to indicate that there are a whole bunch of other terms that happen in here in the middle. And we're going to find the 100th term. Well, if you compute 100 squared, that would be 10,000. And then when you subtract 1, That would be 9,999. So way down the line in the sequence, we would have the number 9,999. So now we're going to focus on the recursive way of writing a sequence. And the way these work, they start off by giving you usually the first term in the sequence, and then they tell you what kind of operation or what pattern you need to apply to find the next term. So for example, they'll indicate to you that you are adding 2 every time, or maybe you're taking the previous term and you're multiplying by 3 to find the next one. So they'll give you the starting point and they'll give you the pattern to use to find the next term. Now, one of the disadvantages of this method is that it does require finding all of the missing terms. So if I ask you for the 10th, you can't just plug 10 into a formula and find what that number will be, the 10th term of the sequence. You'll instead have to start with the first one and then perform the operation to find the second, and then perform the operation to find the third. And you'll have to keep going until you fill in all of the ones leading up to the 10th pattern. One of the things to make it easy to recognize a recursive sequence is it uses variables like a sub n minus 1, which will refer to the previous term in the sequence. Because if a sub n is the current term you're looking at, like the 10th term, then a sub n minus 1 would be the one right before it, the 9th term. Or they might use something like a sub n plus 1. And so kind of the same idea, if a sub n is the 10th term, then a sub n plus 1 would be the 11th term. So it's showing you how to find the next term in the sequence either way. So for a quick example, we're going to look at finding the first 4 terms and then the 8th term of the recursively defined sequence. And the first term in the sequence they're giving to me, that's what b sub 1 means. So the first term in the sequence named b is a 3. Then they're telling me that to find the next term, so if I want to find b sub 2 for a second, then plugging in n equals 2 will tell me that I need to take negative 2 and multiply it by b sub 1, because b sub 2 minus 1 is b sub 1. So basically it's saying take the previous term and multiply it by negative 2. So 3 times negative 2 is negative 6. And then if I wanted to find the third term, so if n equals 3, then this will say b sub 3 equals negative 2 times b sub 2. But basically it's just saying take the previous term and multiply by negative 2, so that would be 12. And then the fourth term would be the third term times negative 2, so negative 24. So I've found the first 4 terms, and then as I said, the disadvantage here is that I can't just skip to the 8th. If I need to know the 8th term, then I'm going to have to keep going and filling in all of the ones in between. So multiply by negative 2 again, multiply by negative 2 again, multiply by negative 2 again, and we have 1, 2, 3, 4, 5, 6, 7, so we need to do one more. So the last number is negative 384. So again, all of this came from the fact that they said the first term is 3. We started with the first term. And then to find every term after that, it's the previous term times negative 2. So start with the term, multiply by negative 2, multiply by negative 2, multiply by negative 2. So this is what we call a recursive sequence. And that's it for the notes for you guys.